Okay, let's talk about significant figures. By the end of this video, you are going to be able to look at a number and tell how many significant figures it has, and you're going to be able to look at calculations and figure out how many significant figures your answer should have. So up first, let's talk about measurement in general. So all measurements consist of two parts. You have a number and a unit. If you just say, for example, that a friend is going to give you 5, you are only telling the number. That doesn't tell us anything about what we're getting. That's just the number. So we have to figure out both parts of this. So every single measurement, it is going to consist of a number and a unit. And later on in the semester too, we might add on to that, but for right now, we've got a number and a unit. These both tell us things. They tell us what exactly it is and how many. We need to have both of that. So if we're saying 5, is it 5 fingers, 5 cents, $5? We need to have this what with it. So when we're specifically looking at these numbers though, we are talking about different types of numbers. So there are really two kinds of numbers that we're going to be talking about in science. And the first one goes by two different names, and they're counted or defined. So if you hear counted or defined, those are going to be a particular type of number. They're not exactly the same thing, and we'll talk about that, but it's the first type of number. And the other type of number, another type of number is a measured number. So let's start with counted and defined. So let's start with counted first. So counted, exactly what it sounds like. It comes from counting. And counting, that number that we get is not subject to error unless you miscount. So if you were counting the number of desks in a classroom and you counted 20, that number doesn't have any error because you've counted it, unless you count wrong and you count 19 and there actually are 20. And our other type of this first is a defined number. So defined numbers are talking about exact relations, and they are not subject to error either. So for example, we're talking about the number of seconds in an hour, or sides on a square, or how many centimeters are in a meter. That would be a defined number. That's an exact relation. There are 24 hours in a day. And then let's move on to measured numbers. So these come from measuring, and these are different. These have a degree of uncertainty to them. So a degree of uncertainty. So when you're measuring something, like for example, the width of your desk, let's say it's 89.5 centimeters. Well, is it really 89.5 centimeters, or is it 89.52, 89.520, etc.? So that being said, we cannot state with exact, absolute certainty what the measurement is. So we've counted and defined are not subject to error, and something that we measure that is subject to uncertainty is subject to error. So this is where we get into significant figures, because not all numbers are exactly the same, and particularly when we're dealing with this measured category. So significant figures, which are sometimes also called significant digits, are the digits in any measurement that are known with certainty, plus the one digit that is estimated. So if you were looking at a measurement, we can know a particular measurement for certainty. Maybe it's marked on a ruler or a graduated cylinder, and then maybe it's kind of between the lines. So we have to guess a little bit. We have to estimate. That's our digit of estimation. So this number of significant figures indicates the preciseness of a measurement. We're going to talk more about preciseness versus being accurate in another lesson, but the preciseness of a measurement. So if you're looking at a ruler and it has a lot of small marks on it versus only a couple of marks, something that has a lot more measurement capabilities is a lot more precise. Okay, next we are going to talk about how to determine how many significant figures are in a number. So for example, if we were talking about the number 500, it only has one sig fig in it. So how can we tell just by looking at the number how many sig figs there are? So in order to do this, there is a rule called the Pacific Atlantic Rule. And the Pacific Atlantic Rule is based on whether or not there is a decimal present. So if the decimal is present, you always start on the Pacific side. If the decimal is absent, you start on the Atlantic side. So let's go through some of these examples on here, and then we'll give you a chance to practice. So if we have a decimal present, we start on the Pacific left side and move across until we find the first non-zero. So here's what this looks like. We're going to start at this 0.0045. The decimal point is present, so we're going to start on the Pacific side and move across to the Atlantic side. So we want to find the first non-zero. Well, that's 0 and that's 0. Haha, 4. That is our non-zero. So that counts as a significant figure. And then 5, that counts too, because we start at this first non-zero and then we just keep counting. So 0.045 has 2 significant figures. So it only has 2 sig figs. Let's do another one. 1.2300. The decimal point is present, so we start on the Pacific side and work our way across. So our decimal point is present. We're going to look for the first non-zero, going this way. 1, that's non-zero, so this is where we start our counting. So we go 1, 2, 3, 4, 5. 1.2300 has 5 sig figs. Okay, let's talk about what if the decimal point is absent. So let's move to the other side here. If the decimal point is absent, we are going to start on the Atlantic side and move across. So decimal point is absent, we go that direction. Let's talk about our first one here. So we have 230,000. The decimal point is absent, we start Atlantic and move our way in. So we're going to count again with the first non-zero. That's where we start our counting. 0, 0, 0, 0. Aha, here's where we start counting. So this one only has 2 significant figures. So 230,000 has 2 significant figures, 2 sig figs. Let's try the next one. 1,750. Once again, the decimal point is absent, so we will move from our Atlantic side over. We start with the first non-zero. Can't start there. We can start here. And then we just check across. So 1,750 has 3 sig figs on it. Let's go ahead and do a little bit of practice here with some other numbers just to make sure we're understanding this. Let's look at these 3 practice problems and try to figure out how many significant figures there are in each of them. So number 1 is 180.50. So we have a point, our decimal is present. So if the decimal point is present, we start on the Pacific side and move to the Atlantic side. So present, we start Pacific, move to Atlantic. And we're going to start counting with our first non-zero. This is not a 0, so we start counting here. 1, 2, 3, 4, 5. This has 5 sig figs. Only worry about the zeros if you're first starting with the 0. Once you've started counting, go ahead, your zeros are sig figs. Why don't you try 2 and 3 on your own, pause the video and try them, and then after you've tried them, hit play on the video and we'll go over them. Okay, hopefully you've tried 2 and 3 on your own, so let's go over these. Number 2, our decimal point is absent. So if our decimal point is absent, we're starting on the Atlantic side and moving in. So it's absent, we start on the Atlantic side. We find our first non-zero. This is a non-zero, and we start counting. 1, 2, 3, 4, 5, 6. This has 6 significant figures. Next, this one, 1,000,000.05. The decimal point is present. We start Pacific and move to Atlantic. First non-zero. That's not a 0, so we start counting here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 9 sig figs. That is a lot. Okay, let's talk now about how to calculate with multiplication, division, and addition and subtraction. For multiplication, we're going to round to the fewest number of significant figures. So let's say you have the multiplication problem, 3.56 times 4.0. If you put this in your calculator, 3.56 times 4.0, you get 14.24. But in order to figure out the number of significant figures, we're going to round to the fewest number of sig figs. We have to calculate them. So looking at 3.56 Pacific present has 1, 2, 3 significant figures. 4.0 decimals present, move present Pacific to Atlantic, it has 2 significant figures. This means our answer is only going to have 2 significant figures in it because that's our least amount. So we need to round this number to 2 significant figures, which means we have to cut off this 0.24. And 0.24 is not enough to round it up to 15, so we have our answer as 14. Let's talk addition and subtraction. So for addition and subtraction, we're going to use the least number of decimals. So let's start by putting this in our calculator here. So we have 20.4 plus 1.322 plus 83. So in the calculator, this comes out to be 104.722. But when we're trying to figure out significant figures for addition and subtraction, we use the least number of decimal places. So if we're looking at decimal places, this one goes out to the 10th, this one goes out even more, and this one doesn't have a decimal point at all. So we need to go to the least number of decimals. Well, 83 doesn't have any, which means we're going to cut our answer off here because 83 has the least amount of precision. So we need to somehow take 104.722 and round it to our ones place. 0.7 is greater than 0.5, so it rounds up, and our final answer is 105. Okay, that is an overview of significant figures. What exactly are measurements, the different types of numbers, and then how to calculate them using the Pacific Atlantic rule, and then specifically looking at addition, subtraction, or multiplication and division. Feel free to rewatch parts of this video and ask questions if you need any help.